Hi! Welcome to my first lesson in AS level chemistry. The first topic to be covered is atomic models. The thing about science in general is that it is theory, based on evidence that we currently have, and it's always changing. Scientists think they know one thing, but then they find out later that they were totally wrong once a better idea comes along. It's always best to keep an open mind because what you thought might have been true might not be true in 50 years, and you don't want to miss out on new ideas. This holds true for the atomic model, so let's go see how it's changed. Can you believe that humans thought about atoms before they even really knew what they were like? Back in 500 BC, this awesome Greek known as Democritus thought everything was made of solid particles, which he called atomos. No ideas like protons or neutrons or electrons yet. He also thought these atomos hooked onto one another with either ball and socket type apparatuses or hooks. I guess he wasn't too far off, but later on we know that these hooks are probably the electrostatic interactions between atoms. British scientist John Dalton in the 1800s, yes, over 2,000 years later, oh my god, started to come up with more specific ideas about atoms. Of note, the most important are as follows. Elements are made of extremely small particles, called atoms. Atoms cannot be created, destroyed, or divided. Atoms of the same element are identical in size, mass, and other properties, and atoms of other elements differ in size and mass and other properties. John Dalton even made the first table with his own symbols of the elements with their atomic masses. Thanks, Wikipedia, for the picture. The British scientist J.J. Thomson in 1897 conducted experiments with cathode ray tubes, which is an apparatus consisting of a tube containing a vacuum with two electrodes at opposite ends. When a voltage is applied, a stream of particles can be seen coming from the negative electrode. So J.J. Thomson had some conclusions from these experiments. Cathode rays are a stream of negatively charged particles called corpuscles, what he called corpuscles. Cathode rays can be deflected by magnets, can be deflected by electric fields, and based on their mass, or based on their velocity, they are particles that are at least 1/2000th the mass of hydrogen, so they're really small. This means that the previous models that said atoms were the smallest unit that made up particles was no longer true. Atoms were made of positive and negative charges that are smaller than the atom itself. J.J. Thomson also concluded that atoms are made of a sea of protons with an equal number of electrons swimming in it, forming an overall neutral charge. He called this the plum pudding atom. Clearly, Thomson had a wild imagination, as this model of the atom does not look like a dessert in any sort of way, but more like vomit. Ugh, but I digress. Another British scientist named Rutherford had his students Hans Geiger and Ernest Marsden challenge the plum pudding model by shooting alpha particles, particles composed of two protons and two neutrons, at a thin sheet of gold foil in 1909. The results of this test were completely different from what they initially expected. What they expected was that if the atoms of the plum pudding were like plum pudding, all of the alpha particles from the test would pass right through without being deflected. What actually happened was a few of the particles deflected back, some at large angles, some of them came back directly at the source, but actually most of them passed right through the gold foil. Based on the results of this test, Rutherford was able to come up with the nuclear atom model in 1911. The nuclear atom model consists of a tiny nucleus that contains positive charges. Negative charges, known as electrons, orbit the nucleus. Plenty of space between the nucleus and electron orbit exists, making up most of the volume of the actual atom. And there is also an equal number of positive and negative charges, creating an overall neutral charge for each atom. Rutherford would later discover these positive charges as protons in 1918. Danish scientist Niels Bohr in 1913 proposed that electrons had to move in ordered orbits called shells, otherwise the electrons would just fall towards a positively charged nucleus in the center. A few more notable scientists are the French Louis de Broglie. I'm sorry, I don't speak French. I don't know how to pronounce that. I'm so sorry. Who in 1923 proposed the idea that particles could have both wave and particle properties. Austrian Erwin Schrödinger in 1926 proposed the idea of wave properties in electrons. 1932, Sir James Chadwick, head scientist of the British team in the Manhattan Project during World War II, smashed alpha particles into other elements and found that uncharged particles with roughly the same mass of a proton popped out, which are called neutrons. More interesting information, as these scientists have gone from a single unit model atomos with ancient Greeks to atoms made of tiny particles called protons, neutrons, and electrons. We know today that these tiny particles are made up of even smaller units called quarks. I won't go into detail here, but here's an overly simplified drawing of a proton and neutron with colorful dots resembling quarks. They probably aren't made of the same ones, since one ends up with a positive charge and the other has no charge. Well, that's all for atomic models. Thank you for watching, and good luck with your studies. Bye!